Welcome to the world of Deeptech. In this video, we will discuss commercialization strategies for advanced technologies. More specifically, we will look at taking a technology developed in research lab, be it in a university or research center, to market. A technology developed in a lab needs to be packaged into a solution that can be delivered to the end user either on its own or as part of another solution. Technology can be commercialized by either licensing it to existing players in the market or creating a new spin-off. From the researcher and research organization perspective, licensing is less risky, faster, and often preferred route to commercialization. Let's look at the factors that determine which path to choose. The first and most important factor to consider is inventors' interest in being engaged in the commercialization of the research. If the inventor is not interested in being involved, then licensing is the best option. The next factor is our ability to package the technology to deliver to third party. This could be blueprints for a new process, clear circuit diagrams, or a piece of software with complete documentation and training. If this is possible, licensing is a better option. The choice between licensing and spin-offs also depends on the maturity of the technology as measured by technology readiness levels and the incumbent industry players' ability to absorb new technologies and deliver the value to their customers. In general, higher the TRL, the higher the probability of success of commercialization of the technology via licensing. Similarly, higher the ability of the industry to absorb and integrate new technologies, the higher the success rate via licensing. Technologies that have a demonstrable, clear market value have a higher success rate of commercialization via licensing. Disruptive technologies that are as yet unproven in the market are harder to commercialize via licensing. Technologies that have higher performance than incumbent solutions are easier to commercialize via licensing than technologies that fit the classic definition of disruptive technologies. Take, for example, organic solar cells. Currently, their performance is well below silicon solar cells, but they are attractive because of other attributes like cost, weight, and flexibility. So, technologies for new organic solar cells are better commercialized using spin-offs rather than licensing. Finally, technologies that offer a solution to an existing market are easier to license than those that are creating new markets. Disruptive technologies that cannot be licensed directly can be commercialized by spinning off a company based on the IP. Let's look at some factors and strategies that spin-offs can adopt. Commercialization strategy adopted by the spin-off company depends on the number and complexity of the development steps needed between the technology and the product or solution. For example, take a new material developed in the lab. You need to ensure that the material produced is of consistent quality in light of fluctuating raw material quality. The material performance should not degrade over time and it should be safe to dispose. Then, the synthesis process needs to be scaled up without impacting quality and consistency. If the process requires specialized equipment, these need to be designed, built, tested, and integrated before the material of consistent quality can be produced in quantities suitable for the market. Commercialization strategy adopted by the spin-off also depends on the distance between your solution and the end user. Going back to our example of material, Let's say the material can be deposited on solar cells to enhance its efficiency. Now, the material has to be formulated into a stable solution that doesn't degrade the performance of the material. You have to optimize the solution and deposition process to ensure uniform deposition. Scale the deposition process and formulations. Figure out how to integrate the process into existing solar cell manufacturing process and so on before the enhanced performance that is promised by the material in the lab reaches the end customer. Many times, the same technology can be applied to create different solutions targeting different customers. For example, let's say I came up with a new technology to synthesize membranes for membrane distillation. The technology could be used for developing membranes suitable for a variety of applications such as water purification, wastewater treatment, or milk processing. Each of these solutions will have to be developed independently and taken to different markets, and the spin-off has to decide which market to go after first early on in the commercialization process. Sometimes this diversity of applications comes downstream where your solution can go into different markets. Let's say you developed a hydrogen fuel cell that has a small footprint. It could be sold to defense industry, transportation industry, or power sector. There is a great deal of customization required for each market, but the fuel cell solution is the same for all these markets. Here, the spin-off can defer the decision about target market to a later stage in the commercialization process. The next consideration for the spin-off is the resources and the time required to go from technology to solution and to take the solution to the end user. Based on all these factors, the spin-off has several options when deciding its commercialization strategy, and these options can be broadly grouped into 4 categories. The first of these is the multiple market strategy, where the spin-off tries to enter multiple markets simultaneously. It is more applicable to the situation where the solution can be deployed into multiple markets like we discussed earlier. This strategy works well when the cost of customization is low and channels for reaching and delivering the solution to different markets overlap. A good example of such product is Office 365. In general, this strategy is resource intensive and risky for startups. The second set of strategies fall under the broad category of multiple licensing. Here, the spin-off is maturing the technology to a solution level for each end user segment, and instead of taking the solution to the end user, is licensing it off to incumbents. This is suitable for situations where the technology development path varies depending on the end user segment, like we saw earlier. This maturation of the technology can potentially be done by licensing the base IP and engaging in joint development agreements with the incumbents. This is a good option when the development cost and time required for the customized solution are high. However, since the spin-off is not taking the technology all the way to the market, the revenue generated is relatively lower and the success strategy depends on the TRL of the technology. The higher the commonality between the technology development path and level of transferability of know-how between the segments, the higher the success of this approach. The third category is the niche strategy. Let's look at it a little closely. In general, advanced technologies can potentially disrupt the existing markets along more than one dimension. For example, it can lower capex, OPEX and have higher performance. But the readiness level of the technologies means that they are often risky long-term investments. In certain situations, it's possible to reduce this risk by taking a more evolutionary approach. For example, if we take the drone technology, current solutions have limitations both in terms of range and payload. Instead of going from current state to long range, large payload systems in a single step, we could find niche applications for these limited range small payload systems, and as we evolve the technology, expand the applications towards more mainstream markets. The precondition for such an approach to work is that investment required for each of these evolutionary steps is small enough and that the returns from such evolutionary steps are attractive enough for the investors. But if you are dependent on a number of external partnerships for components or manufacturing facilities, etc., the niche strategy doesn't necessarily reduce that risk. The fourth set of strategies are based on the ecosystem. Let's take a look at them closely. Ecosystem-based strategies are particularly suitable for spin-offs when there are a number of complex and interdependent steps from technology to solution, and the solution needs to be integrated further down the value chain before reaching the customer, as is common in renewable energy solutions or advanced material related solutions. To successfully commercialize such technologies, the spin-offs need to form a number of partnerships. The first and most obvious partnership that the spin-off forms is with its parent lab. Since the commercialization timescales can span several years, the spin-off needs to continue the development of technology to ensure that the expiration of its patents doesn't jeopardize its competitive positioning, and partnership with the parent lab enables the spin-off to continue developing this next-gen IP. In addition, partnership with the parent lab also gives it access to facilities and potential recruits to its team as the spin-off grows. Simultaneously, it needs to progress the technology it currently holds towards the market. Here, it can benefit from partnership with other labs where it can access complementary IP and facilities not available to it from the parent lab. Partnership with other startups is often an underutilized resource. Although startups in the same incubator tend to have informal interactions at different levels. However, it can be a great way to get access and even acquire complementary IP and team. Young companies developing advanced technologies need to find corporate and development partners and investors. They often encounter an uncertain future due to lack of clarity on regulation and standards applicable to their solutions. A proactive government can help these companies by creating consortiums comprising of incumbents and investors, by incentivizing partnerships with the right funding schemes, and by actively engaging different stakeholders to define standards and regulatory requirements. Young companies should take the time and effort to participate in such government efforts and actively engage with the stakeholders. The most well-known and sought-after partnership by young companies is the partnership with corporates, who not only bring market access and information, but also know-how and facilities required to take the startup's technology and solution closer to the end user. They can also bring in expertise necessary to scale up the startup's solution. As we discussed earlier, advanced technology spin-offs often have a choice of different solutions and end-user segments to target, and partnerships we just discussed can help them identify the right value chain or value chains to focus on by doing systematic identification and review of market opportunities rather than going with the first available partner. The choice of value chain should be based not just on the attractiveness of the market, but also on the availability of right industry ecosystem and on the willingness of the potential partners to add value to the startup's commercialization effort. As discussed earlier, of all the partnerships, spin-offs consider corporate partnerships as the most important and valuable, as it offers several advantages. These include credibility and revenue streams from IP licensing and collaborative agreements, and the investments that these two bring. Corporate partnerships also enable the spin-off secure timely feedback for optimal product development and reduces time to market because of the development know-how, market information, and other expertise that the corporate partners bring. It provides the spin-off company with the ability to establish influence across the value chain. These kind of partnerships also allow the company to commercialize invention in more than one value chain if it chooses to do so, and provides it with an ability to systematically identify and review market opportunities, thereby diversifying risk. On the downside, if the spin-off limits these partnerships to single incumbent, it will narrow the focus of the spin-off to the incumbent. The spin-off will also be susceptible to changing fortunes of the corporate and may delay market entry, as the spin-off solution is essentially a keep-for solution for the corporate and it may fall off the corporate's immediate priority list during tough times. Spin-offs can protect themselves from these downsides by partnering with several corporates and signing licensing agreements with these partners that give each exclusivity over specific geography, field of use, or over limited period of time. The selected partner should ideally have financial liquidity, have complementary innovations that can push the spin-off's technology forward in the value chain, have systems in place for strong IP protection, and a track record of successful partnerships with young companies. Also, if the spin-off doesn't keep its focus while building partnerships with corporates, its IP is likely to leak away to corporates, thereby weakening its position in the value chain. If you look at the evolution of the technology towards market, we can split it into technology value chain, where we take the technology and convert it to a solution, and market value chain, where the solution gets integrated in existing systems that the end user can actually use and obtain value. The point at which this phase transition happens is the decoupling point. This is the point in the value chain where there is a modular interface with the next stage of the value added. In our earlier example of creating a membrane for membrane distillation column, the development of the membrane and its scale-up is the decoupling point at which the membrane can be handed off to the next part of the value chain. The spin-off should ensure its IP and influence in the value chain are secure at least till this decoupling point, beyond which the corporates can take over. If done right, the ecosystem strategies can help spin-offs become robust and lower its dependence risk. Forming and managing these partnerships is complex, but they have the potential to increase the probability of success of the most upstream and generic of advanced technology-based spin-offs. I hope this gives you an overview of the various strategies for commercializing advanced technologies from lab to market. Thank you. Oh, before you leave, don't forget to subscribe to this channel and like this video. Thank you once again.